7.6 double angle identities. So above is all of the double angle identities that we could be using. And so let's apply those. So given angle theta is standard position with terminal arm in quadrant 4 and cos theta equals 2 over 5, determine the exact value of each trigonometric ratio. So because we're going to need to know the sine, we're going to have to know the y value. So we know cos is x over r, sine is y over r, tangent is y over x. So we're going to use quadrant 4, and we have x, we have y, we have r, and our x value is going to be 2, and it's positive because it's in quadrant 4. Our r value is always positive, and we know we're going to get a y value that's going to be negative. So we're going to use the fact that we know that x squared plus y squared is equal to r squared. So r is equal to the square root, just kidding, we're looking for y. Y is equal to the square root of plus or minus r squared minus x squared. So y equals plus or minus, our r value is 5, so 5 squared subtract 2 squared, and what we get here is the square root of 21. And again, because it's in quadrant 4, it's going to be negative. So there are our x, y, and r values. So we're going to evaluate, let's do this sine of 2 pi. So we can rewrite sine of 2 pi as 2 sine theta cos theta. And we know that it's going to be 2. Our sine theta will be y over r, which is 5. Our cos theta is going to be x over r, which is 5. And now we'll just simplify. So we have 2 times 2, which is 4, times negative 1. So we have negative 4 root 21 over 25. Now we're going to go to cos 2 theta. So there's a whole bunch of different ones we can do. So I don't know, let's pick this one. So cos 2 theta is going to change to be cos squared theta minus 1. So we can replace cos theta with 2 over 5. So we have 2 times 2 over 5 squared minus 1. Make sure to distribute that square to the top and the bottom. So we have 2 times 4 over 25, subtract 1. So that's 8 over 25, subtract 1. Remember that 1 is the same as saying 25 out of 25. So 8 subtract 25 out of 25 will give us negative 17 over 25. And that is our exact solution. Alright, next one. We have cos 2 squared of pi over 4 minus sine squared of pi over 4. So I'm going to look and I can see that we have a cos squared theta minus a sine squared theta. So that's going to turn into a cos 2 of theta. And our theta is pi over 4. And then what we're going to do is we're going to multiply this in. So we have cos of 2 pi over 4, which is cos of pi over 2. So we can use our unit circle, and when I can go to cos of pi over 2 is right there. So my answer is 0. I'll just delete it. Okay, let's do the next one. So we have 2 tan theta over tan squared theta minus 1. So what I'm noticing is it's kind of like this. The only difference is on the bottom, these are backwards. So what I'm going to do is I'm going to take out a negative 1. So we have 2 tan pi over 6 over negative 1. And then I can rewrite this as 1 minus tan squared pi over 6. And now we can change it to be negative tan 2 theta, so pi over 6. We can change that to be negative tan of 2 pi over 6, which is negative tan of pi over 3. Now I'll get out my unit circle, and I'll go to pi over 3. So pi over 3 is right here. So to find my tan, I'm going to take the y and divide it by the x. So we have negative, and then we have root 3 over 1. So our answer is negative root 3. And that one is done. Okay, flip the page. 2 more examples. Okay, we are going to prove the following identities. So something I'm just going to say about proofs, which I might not have said earlier, I can't actually remember. I've made so many videos in such a short amount of time. I don't even know. All I'm going to say is there's more than one way to do it, and you're only going to get good at it if you practice it. And sometimes when you make mistakes, your mistakes will actually tell you and help you find the right way to do it. So you kind of just have to keep working your way through it. But again, if you're not practicing this, this is not something that you're just going to get. Okay, so let's start. We got a cos 2 theta here. Let's try changing it to something else. So let's change it to, I don't know. Let's do this one. Let's try that. So we have cos squared theta minus sine squared theta plus 1. And on the bottom, we're going to change it to this. So we have 2 sine theta cos theta. Now, what I'm going to do is I'm going to write out all the other identities because we need to use all of them now. Okay, instead of writing them all out, I just got a picture. Okay, so let's think about this. So I see I have some sine squareds and a 1. So that's reminding me that I can change cos squared theta to be 1 minus sine squared theta. So if I rearrange this to be cos squared theta and make it plus 1 minus sine squared theta over 2 sine theta cos theta, now I can see that I can easily apply this identity over here. So I can change 1 minus sine squared theta to be another cos squared theta. So I have cos squared theta plus cos squared theta over 2 sine theta cos theta. So this is the same as saying 2 cos squared theta over sine theta cos theta times 2. Our 2's are going to cancel, and one of our cosines is going to cancel, so we're going to be left with cos theta over sine theta. And now applying my knowledge that cos theta over sine theta is cotangent theta, we get cotangent theta equals cotangent theta. Amazing. Everything worked out wonderfully. So we got the left side to equal the right side. Great job. I'm recognizing that I am mostly congratulating myself for getting the question right, but I'm hoping that you're there with me. And I'll never stop congratulating myself. I deserve it. Okay, example 2. So we have cotangent theta cosecant theta equals 1 over 2 sine squared theta. So I'm going to change this left side because, I don't know, I just got a feeling about it. It looks like it's going to be easier to change into 2 sine squared theta than trying to change that to something else. So I know that cotangent theta is cos theta over sine theta. So let's start with that. And I know that cosecant 2 theta is the same as the reciprocal of sine. So it'd be 1 over sine 2 theta. And now I'm going to use my double angle identity here and change it right there. So I have cos theta over sine theta times 1 over 2 sine theta cos theta. And now I can cancel because we're multiplying, so I have a cos theta here and I have a cos theta here, so I'm left with 1 on the top. On the bottom I have a 2, and I have sine theta times sine theta, so I have sine squared theta. And it's done. Ta-da! Okay, that proof was generally pretty easy. The proofs that are going to be in your workbook are a lot harder, and you need to be doing those ones. I also put really hard proofs on the practice test, which I have for you. So just make sure you try some of those. If you don't practice, it's going to be a gong show. So just something with this rule right here. Don't forget that if it's like sine squared theta, you can make it 1 over cosecant squared theta. And if you have sine 2 theta over cos 2 theta, you can go ahead and make that tan 2 theta. These rules still apply even with a 2 or if it's squared. Okay, last example. So we're going to solve the equation 1/2 sine 2x minus cos 2x equals 0. So I'm just going to write that out again. Oops. Sine 2x minus cos squared x equals 0. Okay, so let's start with changing this double identity. So we have 1/2 times 2 sine x cos x minus cos squared x. This 2 and this 2 are going to cancel. So I have sine x cos x minus cos squared x. I'm now noticing that I have a cos x in both of these, so I'm going to factor one of these out. So I have cos x, and I'm left with sine x minus cosine x. And now we're going to solve each of these for 0. So we're going to first solve cos x equals 0. And I'm going to get out a unit circle. So on my unit circle, cos is 0 up here at 90 degrees, or pi over 2. And we're also solving it for 0 to 2 pi, so it's also going to be 0 here. So our answers are pi over 2 and 3 pi over 2. So that's our first answers. Next answers, we have sine x minus cosine x equals 0. I'm going to move the cosine x to the other side. And we did do an example of this earlier. What I'm going to do here is I'm going to divide both sides by cos x. And what this does is it allows me to turn this side into a tangent x and this side into a 1. And tangent is going to be 1 at right here, 1 over 1. It's also going to be positive down here at -1 over -1. So our answers would be pi over 4 and x equals 5 pi over 4. And that is the end of trigonometry. For some of you, this is the last lesson of Pre-Cal 30, so you've done amazing, and you stay classy, San Diego. Okay, bye.